Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Apa khabar? How are you? Everybody okay? Huh?
Okay.
So before we start class today, I would like to just discuss a little bit about the quiz. I was thinking, if I give you the quiz next week during the break, is it okay with you?
Okay.
Yes,
okay.
right? Because now it's EAP.
Okay.
Yes.
So I was thinking, I want to give you extra time to study, at least the weekend. So if I give you on Monday next week, okay? Monday must break.
Okay.
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 Friday. Because I can give you Saturday and Sunday, the weekend to study. Hopefully, time for studying, at least, you can improve. Yeah? Saturday, okay. So I was thinking about Saturday. Because Saturday, the time is in the afternoon. What about after Asar? So we will do the quiz on Monday. The 23rd. Today is 18. Let me check the calendar. Monday is the 20th. Yes, during the break. So 23rd November. And the time is 5 p.m. Okay, 5. I'll give you probably 40 minutes. 5 to 5:40 p.m. The time, how long the time is, I will let you know. Probably 1 hour, or 1 hour. And as I said earlier, we will start Zoom, okay? We'll start Zoom class. And then I will put the question in the classroom. So you submit everything classroom, okay? All right. And the coverage will be everything up to what we learned today.
Sorry,
Okay,
sir.
so that will include, of course, chapter 10. Okay. Any question?
Sir.
Anything?
Sir.
Yeah.
I have test at 23rd.
What time? What time is your
23.
test? Huh?
5. Also 5 p.m.
5 p.m. Go?
Yes.
5 p.m. Then 5 p.m. because the Zoom, this Zoom is being used by the department, for the day. In that case, we will do it on 4, 5, 6. What test did you have? What was the test? Test on what? Test subject apa tu?
Sir.
Huh?
Sustainable development.
What time will it finish?
I think in 1 hour, 5 to 6.
Okay. So in that case, we cannot do that, or we cannot do it on Monday. Then we'll do that on Wednesday. Okay. Wednesday, the 25th. And then we make it during the class time, 10 a.m. Right. Boleh. Or we can do it on Tuesday. Okay, so another option is Tuesday. On the 24th. This one would be on 12th. Okay, 12 noon. Okay, which one do you prefer? Wednesday or Tuesday?
Wednesday.
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 Okay. So we'll do it
Wednesday.
Wednesday class time, right? So the time period duration will be about 1 hour or 40 minutes. Okay. All right. So to set the time for the quiz settle, it will be Wednesday on the 25th. That would be 10 a.m. All right. Okay. Everybody should take. Okay. Now, if you miss without valid excuse or valid reason, that means it's considered as absent. So today, I'm sorry, somebody is using chainsaw, beside my house. I don't know what they are cutting. Maybe they're cutting a tree. Okay, I will continue from where we left last time. I would like to look at the cubic function. So go back to example number on the chapter 10, that example that we were doing. The example, chapter number 10, the cubic function, because we just want to make sure that we know how to factor the x, or you want to know how to find the roots of the function. Okay, so if you look at a cubic function, that is the example I'm looking at, example in 10.1. So example in 10.1, you see there you have the quadratic function or the cubic function, y equal to 1 over 3 x cubed. Now, can you hear me? Because that sound, is quite loud, that machine. Can you hear me? Can you hear me? Okay.
Yes, we can hear
tak
you.
clear?
Okay, okay, sir.
Yeah, clear, sir.
Boleh ya?
Clear, clear.
Benda tu
Yes,
kuat
sir.
juga tu. Saya ingatkan dah
Clear,
habis
clear.
lah. Punya tu lagi. Okay, you got x squared minus 3x plus 2. So when you take the derivative of the y, you got y prime. The function of the derivative is a quadratic function. So you got x squared minus 2x minus 3. Okay? So you got a quadratic function here. So now you want to find x. Okay, there are two ways. Number one is you look at the formula. The formula is given in chapter 2.1. The formula is you want to find x. That will be x equal to, that's a general formula. Okay, so for general formula, you got the quadratic function, you got ax squared plus bx plus c equal to 0. And then you got the x, how we find x, equal to negative b plus or minus b squared minus 4ac, everything divided by 2a. So if you don't know the shortcut method, you do this way. Okay, and there is a shortcut method. Now this shortcut method, if you take hisab tambahan, probably you learn it. It's the cross method. Very simple and accurate. But this is a general method. Okay, so everybody should know this method. So if you want to find the value, the roots or the critical points for a cubic function, then remember this formula. Okay, don't just give me the value of x. because how you get it is important. So coming back to here, so for critical point, y prime equal to 0. So that means x squared minus 2x minus 3 equal to 0. So you apply that formula. Okay, so a equal to 1, b equal to -2, c equal to -3, then you will get x. Okay, now the other method, if you look at the book, they just give you directly, you know, x plus 1, x minus 3. So by that method, what we do here is this. We call it cross method. You got here x, you got x. Okay, and then the -3, you multiply by the x and x, you must have -2. So how do you do that? You got -3, 1. So -3x plus x, you got -2. So that's how you do it. And there, you will get x plus 1, x minus 3 equal to 0. Now, if you do this method, okay, then you get that thing right. If you don't know this method, okay, then you have to do the general method. So make sure you remember the formula. This is a very basic formula for quadratic function. All right. So that is the cubic function. And the roots for the cubic function is a quadratic function. So therefore, to find the x or the critical points, you have to use that formula. Or if you know this one, you know, it's good. So after that, you will get the critical points, x equal to -1, x equal to 3. And of course, you have to find the y over here, find the y over there, all right? And then take the second derivative and do the test. You will get maximum or minimum at each point. So those were the homework questions that I gave you last class. Okay, any problem with the homework question? Anything? No? Okay, good. Now, the other one that I would like to mention, this is just for brief mention, is inflection point. Now, if you go to the chapter 10.2, they give you inflection point. Now, what is an inflection point? Inflection point is something like this. You have the curve, all right? The curve inflection point meaning be something like this, inflection point. It is not a maximum, neither it is a minimum. So if you look at a maximum, the curve will go up like that, reaching a critical point here, y prime equal to 0, there. So let's say this is x, 0. Now, instead of the curve going down for a maximum, the curve go up again. So it is a behavior reaching the critical point, and then it goes up again. So that point is no more maximum. So we call this inflection point. All right. So inflection point is not important for us to continue solving the problem. If you have inflection point, then you just say may have inflection point, we stop there. Or in another possibility, you may have something like this. The curve is going down like that. All right. And we're supposed to have a minimum here. You know, the curve should go up. But instead of the curve going up, it will continue going down again. So that's also inflection point. So inflection point is the y prime 0. You may have y prime equal to 0, or sometimes y prime is not 0. So you have it. You also have another type of inflection point. But for us, since we are talking about critical point, we only worry about the inflection point where the y prime is 0, right? Because you want to know whether that critical point is a maximum or minimum. Sometimes it may happen, it is not a maximum, neither it is a minimum, it's an inflection point. So inflection point is something like that. But the curve will behave that way. All right. So just to have an idea of inflection point. Okay. Any question? Anything? Any comment? All right. So that part on the inflection point, we don't do much. We just need to know what is inflection point. All right. So what we do now is we move on to the last part of the chapter on the application. Okay, application here. Like I said earlier, applications are on cost, revenue, profit. So let's do that. So we started already with the first application, the average cost. That is example number 3. You have the average cost. You're given the cost function. You want to find the quantity that give you the minimum average cost, or the quantity that minimize average cost. And you want to find what is the minimum average cost. Okay, so what we do here is we apply the second derivative. All right, so you will know the cost. So you want to find average cost. Average cost is C over X, the cost divided by the quantity. So that would be equal to what? That would be equal to the cost is given. Okay, the cost is given divided by the X, and then I will just give you the cost function. So it is equal to 1 over 4 X plus 4. Now you have the third term, 100 divided by X. So bring the X up, so that becomes 100X minus 1. All right. So number 1, we find critical point. You find AC prime, and that is equal to 0 for critical point. Critical point can be maximum, can be minimum. So first thing, critical point. So what is AC prime? AC prime is equal to 1 over 4, right? Plus, you got negative 1 to the power of X. So you got negative 100X multiplied by X, reduced the power by 1, that becomes X to the power of negative 2. Set that to 0. Okay, AC prime equal to 0. That means 1 over 4 minus 100. Okay, now you can bring the X down again to become X to the power of 2 equal 0. Okay, so how do you find X? You bring the other term to the other side. So you got 100 over X squared equal to 1 over 4. You cross multiply, you will get X squared equal to 400. Okay, X squared equal to 400. Therefore, X is equal to the square root of 400, or 400 to the power of half. That will be equal to what? Plus or minus 220. Okay, so X is equal to negative 20 and positive 20. So X equal to 20, X equal to negative 20. Now for application, because this is application, for application, we don't consider negative output, all right? So you don't have to worry about the negative output. So we just say that for application, for real life things, you know, X less than 0, not relevant. Because how do we consider negative output or negative value of a variable? So therefore, X is only equal to 20. So this is the critical point that we need to consider. Number 2, what do we take? We take the second derivative. So AC double prime is equal to what? It's equal to, now you have the AC prime Okay, SE prime is equal to this thing here. When you take the derivative, we go back to the first form. Okay, that one. So what is the derivative of the AC prime now? Becomes AC double prime. What is it equal to?
100 x
200
200
x
multiplied by
power
x negative 3.
x to the power of negative 3. Okay, and then you bring the x to the power of negative 3 downward, becomes 100, 200 divided by x cubed. So AC double prime is equal to 200 x to the power of negative 3. And of course, you can write it as 200 over x to the power of 3. So that is our AC prime. Now, you want to test for maximum or minimum. So what we do at the critical point, you find the value of AC double prime. By substitution, you will get 20 to the power of 3. And of course, that is positive. So what is our conclusion? Our conclusion is saying that, so the average cost function has a relative, okay, or you don't have to put the word relative, have a minimum at x equal 20. So now you have to find the minimum average cost. So how do we find the minimum average cost? Substitute into what? So now we substitute x equal to 20 into the average cost function. Okay? So you substitute that x equal to 20 into the average cost function. So you will get the minimum average cost. So what do you get? If you do that, you will get how much? You will get, work it out, all right? You'll get it, average cost equal to $14. So our conclusion would be, you say, okay, the average cost has a relative minimum at x equal to 20. All right, and then the average cost is 14. So what we do, we make a conclusion. The average cost, okay, the average cost is minimum. Or I think we say it the other one around. To minimize the average cost. I think this one sounds better. To minimize the average cost, you have to produce how much? Produce 20 units of the output. What is the output here? It doesn't say. So 20 units of the output of the good. And we write the minimum average cost is $14. All right. So what we do here, we describe the critical point, or in other words, the minimum point. Okay. You describe the value of the x, which is here x, and you describe what do we mean by the value of the y, which is the average cost. Okay. All right. Anything about this example? Okay, now that's example number 3. Now you move on, you go to example number 4. Now example number 4 is on the profit. Now profit, as I mentioned earlier, you have 2 types of market. One is the competitive market, all right? The other is the monopoly market. So the difference is not on the profit. It's not big, it's not due to the directly on the profit. It's the difference is on what? It's on the revenue. Okay, revenue R. Because right? Profit is equal to revenue minus the cost. So this one shouldn't be a problem. Some problem may arise from the R. So R is equal to P multiplied by X. So I think I mentioned this earlier, but I'm going to repeat again. You have two types of market. One is the perfect competition, competitive market. This is where the price is constant. Call it P bar. Okay, price constant. So P is just equal to P bar. So your revenue will be just equal to P bar multiplied by X. Example, if the price equal to say 150, so revenue is equal to 150 multiplied by X. This is just linear function. Now, on the other hand, if you have monopoly, okay, monopoly, what about the price? Is the price constant? Price is not constant, right? Price is variable. So the price is given by what? By the demand function. So you get the price from the demand function. So therefore, the revenue will be equal to not a linear function, all right? Will be equal to some non-linear function because the price is a variable or given by demand function. Example, let's say the price is equal to 170 minus 0.5x. So what is the revenue? Revenue is equal to 170 minus 0.5x multiplied by x. You will get a nonlinear function. So the profit would be, profit function would be different, okay? Because due to the revenue function. So you need to look at, all right? Normally they will give you, in order for you to find the profit, normally the question or the problem will give you the price. Is the price constant? Or they give you the demand function. All right, so we have to know. If it is given the demand function, that means it's a monopoly market. Then you will use that demand function to get the revenue. So let's look at example number 4. Okay, example number 4 is already been given the profit. So that example 4 is similar to the example that we were doing earlier. Not really the it's a cubic function. Correct. So that is similar to the example, the first example that we're doing. Example in 10.1. You know that is not profit. It's this. It's a cubic function. You get the derivative quadratic. So similar to that. Okay. So I want you to read that example number 4. So example 4, I want you to go home, read it. Okay. Read and do it. Do it. Now I want to look at example number 5 and example number 6. So we start with example number 6 because example number 6 is on the competitive market. So if you look at the example number 6, can you go through that example for a few minutes so that we can formulate the revenue and then come up with the cost so we can get the profit. Okay, read it for a few minutes. Okay, you got it? So here you have the price given. Is that right? The firm, they already give you the competitive market. The price is 200, and then the average cost is given. So you want to find what is the output level that should be sold in order to maximize profit, and what is the maximum profit. So here you want to maximize profit. And of course, we know profit is equal to what? Profit equal to revenue minus cost. So you got to find revenue. So now, firstly, you find the revenue. And we know revenue is equal to P times X. Therefore, given the price equal to 200, that is 200X. So linear function, revenue. Now, to find the cost, how do you find the cost function? Cost function, you are given what? You are given the average cost. So from the average cost, you want to find cost, you multiply by the output level. All right? So you get the average cost times the output level. That will give you the cost function. So that will be equal to 80 plus X multiplied by X. So what do we get? We get 80X plus X squared. So the profit will be equal to the revenue minus cost. That will be equal to 200 minus 80X plus X squared. You break out the bracket. Now you break out the bracket, make sure you take care of the signs, okay? So the sign here is positive, so make sure it becomes negative. Some people, they only look at that one. So I'm telling you now because it may happen, you know, mistake. So you got 200 minus 80X plus X squared. Now that is wrong because you have a negative sign here, but the cost is not 80X. The cost is what? The cost is everything in the bracket. So you have to do it term by term to make sure that you have end up with the correct sign. So what is it equal to? 200 minus 800. I'm sorry, not 800, 80X minus 80X. Now here, you have a negative plus sign, a negative. So that becomes a negative X squared. Betul? Betul kita betul? Okay. So that is our profit function. Now you have to find the profit. You have to find the profit. No, you have to find the profit. You have to find the P prime. Take the derivative of P. That means P prime. Okay. So what is P prime? P prime is equal to negative 80. Negative. Yeah. Is that right? Yeah, that's correct. Negative 80 minus 2X.
Sir,
I think ada something wrong ni. Mana dia?
200
It's 200X.
we have X.
Oh yeah, yeah.
200X.
Ada X. Yeah, that come from here. Okay, thank you. We missed that X. So you should have an X over there. No wonder now. No, you know, because I have that negative 80, so that become a negative number. So that doesn't make sense. So somewhere we have a mistake somewhere. So that's the mistake. So it should be 200X minus 80X minus X squared. So before we do that, we simplify that thing first. So if you do that, that means you will get 120X.
Yes.
So the 120X. Okay, I'm not going to write it down. I will just do it and then take the derivative. So this one will become 120 minus 2X. Yang ini betul tak? Okay. So for critical point, the P prime is set to 0. So therefore, 120 minus 2X equals 0. X equal to 120 over 2. That would equal to 60. So that is the critical point. or the critical value of X. Now, based on that, find the cost, okay? You have to find the cost at that point. So you have to find the cost at X equal 60. Or normally, we don't do that yet, you know? We test whether you have a maximum or minimum at that X equal to 60. So we can go ahead and get the second derivative, okay? So test for minimum. All right, you want to test for minimum because you want to minimize the cost. Okay, so if you do for minimum, that means the second derivative of the cost, evaluate at X equal to 20. It must be what? It must be positive, or it must be, or it is negative. It must be positive. Okay, so to test for minimum, you must have positive. The value of the C double prime at X equal 20. So what is the C double prime? The C double prime is equal to negative 2. Okay, C double prime is equal, oh, we're not doing C prime. I'm sorry. Kita bukan buat cost, kita buat profit. Saya ingat cost. Pula bising kat belakang tu. You know? Kacau. Bunyi lagi tu. Tadi kat sana, sekarang ni kat situ pula. Banyak tu pokok di depan. Okay. So, it's not C double prime. I'm sorry. It's the profit. Okay. So for profit, you will do this. Get the P double prime. Okay. Now, when you get the P double prime, okay, finish it up. All right. You get the P double prime, and then we have to test. All right. You have to test whether that P double prime, is it negative or is it positive for maximum? Because you have to do maximum. That means you have to have the P double prime at X equal to 20. It should be what? It should be negative. So get the P double prime. Do you have a negative or you don't have negative?
Negative.
You have a negative, right? So P double prime, if you do the second derivative, is equal to negative 2. Okay? It's a constant, so very easy. But you have to test, all right, at X equal to 20, just a formality. To show that P double prime at X equal to 20, it is in fact negative. So at X equal to 20, P double prime is also equal to 2 because it's a constant. And that is less than 0. So you have P is maximized, or P is maximum at X equal 20. Next, you have to find what is the maximum profit. Okay, to find the maximum profit, you substitute X into the P. All right, so X, which is equal to 20, into the profit function. So what do you get? If you do the substitution, you will get berapa? This example, they don't get the maximum profit. They will just get the X. I want you to substitute into the P. What is the maximum profit? X bukan 20. Berapa X?
60.
60.
Upset tak cakap. Kan, I got it here 60. When I do that way, from there, I got 20. So, it's not 20, it's 60.
3,600, sir.
So you get the profit at the 60, not 20 lah, no 60. If you put 20, that we get a different, wrong value. So if you put 60, berapa dapat?
3,600.
You put into the profit function, that will be equal to 3,600.
600.
All right, so that is the maximum point. Now you have to describe lah. Okay, the conclusion would be what? To maximize profit, or you can say that the profit is maximum, or you can say to maximize profit, we have to sell 60 units. What is the product here? Dia tak cakap benda. Okay, tak cakap apa, jadi 60 units of the product lah. Alright, you sell 60 units of the product, and the maximum profit is, because the unit here is dollars, so the maximum profit is $3,600. So that is our conclusion. All right. So that is example number 6. The profit for perfect competition. Now go to example above it, the example number 5. You will get an example profit in a monopoly. So I want you to just read the first part, okay? The first part. That means information on the price and information on the cost. And then we can get the profit function. So just read for a few minutes, and then you will get the revenue. You will get the cost function. Okay, you got it? All right. Now, like I said earlier, firstly, you need to find the revenue, and then you get the cost. So let's do that. So again here, you want to find the output level that maximize the profit, and we need also to find the maximum profit. So basically, profit maximization problem, we apply the second derivative test. So we are given the profit equal to revenue minus cost, right? Now, number 1, you need to find revenue. Revenue is equal to P times X. And now, given the demand function, so that will be the price, right? Be equal to 168 minus 0.2x multiplied by x. So that is our revenue function. We got 168x minus 0.2x squared. So that's our revenue. Now, cost. You need to find cost. It's not given cost, it's given average cost again. So you have the average cost equal to 120 plus x. So average cost is multiplied by x. That give you the cost. So we get 120 plus x multiplied by x. That will be equal to 120x plus x squared. So that is our cost function. And then we get the profit. So therefore, the profit is equal to 168x minus 0.2x squared. Now you minus the cost, the whole thing for the cost. So 120x plus x squared. Okay, break out the bracket. Okay, so make sure you break out it correctly. So you break out the bracket, you will get become negative. Okay. So 168 minus 120, that becomes 48x. And then you got a negative 0.2 minus 1, that becomes 1.2x squared. Is that right? So you got that cost revenue. I mean profit function. So I want you to finish this up. All right. So I want you to find the critical point. Okay. And then do the second derivative test for maximization. Okay, finish it up. Everything is given in the book. Okay, I don't want you to look at the book. I want you to do it by yourself. So finish it up. You look at the book after you have done the work. Okay, then you can check the book. Okay, do it now. I give you 5 minutes. Hello. 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 Oke, nanti kan saya telepon balik. Nah, Assalamualaikum. Okay, you got it. So you got first, to find the P prime. Okay. So P prime is equal to what? First of all, find the critical point. All right. So P prime is equal to the derivative of that P. So you get 48 minus 2.4x. So 48 minus 2.4x. And we know for the critical point, okay, for critical point, that would be equal to 0. Okay, P prime equal 0. So therefore 48 minus 2.4 x equal to 0. X equal to 48 divided by 2.4. 48 divided by 2.4. Berapa?
20.
20.
20. Equal to 20. So that is the critical point. Now you want to test whether it's maximum. So you got to have, P double prime at x equal to 20 would be negative. So P double prime is equal to negative 2.4. And it's a constant function, it's easy. So we just make it formal at x equal to 20. P double prime at 20 is equal to negative 2.4. So that is less than 0. Profit is maximum at x equal 20. Next, you have to find what is the maximum profit. All right, what is the maximum profit? You substitute into the profit function. So you will get the value and then do the description. You just describe that that point. Okay, so you finish it up. Now for the example for that chapter 10.3, I want to give you some questions. Okay, do number 6. Okay, number 6 is revenue. And then do number 17. That's for cost. Average cost. And then we do number 26. Okay, that's for profit. And then do also number 27. So I think that we have enough question already. We'll give you one more. Monopoly the price. Negara revenue. Ada soalan tak yang dia bagi different function where the price,
Cantik tu beg yang aku beli ni sesuai dengan
satu
baju
lagi.
aku.
Number 38. 38 tu bagus. Okay, number 38 you should do. Okay, 38 and maybe 39. Alright. So these are the questions I want you to do. At least, okay, do some of them. All right, I want you to do number 6, revenue, you should do, 17. For the profit maximization, at least do these two things. Okay, all right. Now, anything for chapter number 10? So we have completed chapter 10. Okay, chapter 10 finished. So chapter 10 finished. We have 3 or 4 more topics to cover, during the second half. 6 more weeks. So what I will do, the less important parts we'll skip. Okay, the less important part we skip, and then we will try to cover the syllabus. So I think I will do that because we are shortened by 2 weeks. That is a lot of time. I didn't realize that the semester was only 12 weeks until one of my students informed me. So that is end of chapter number 10. Now, what we will want to do next is we move on to the next topic. Now, the next topic, since we are doing derivative, okay, we will continue with the derivative, and that would be chapter number 14. Okay, chapter number 14. Chapter number 14. Chapter number 14. It's in the yeah, here I got it. Because that book, the book that you have, we don't have chapter 14. So for 14, you have to. I do not know whether the online book has the chapter number 14. But if it is hardcover, hard copy, chapter number 14, it comes on their own. They have another totally different book, but of course, smaller one on chapter 14 and a few other chapters. So what we're doing now is chapter number 14. Chapter number 14 is what you call the partial derivative. So here we are dealing with partial derivative. Now, partial derivative is where you have a function with more than one independent variable. What we have been looking at, so far is y is a function of x. But this chapter, you will deal with a function, y, is not just a function of x. It's a function of more than one independent variables. So we call it x1, x2, x3, up to xn, where n is an integer, and x1 and x2 are independent variables. So you have more than one independent variables. Example, you have y as a function of x1, x2, x3. So you have 3 independent variables. All right. So when you have more than one independent variables, you want to take the derivative, we do the partial derivative. So why partial derivative? Because you do the derivative with respect to only one variable at a time. Okay, one independent variable, because you have more than one independent variable at a time. So that's why you call it partial. All right, because you take it, or you take the derivative of y with respect to only one independent variable at a time. And then you have to do it for the other variable also at one time. So that is the concept, or not the concept, the idea why they call it partial derivative. Now for us, okay, we only consider 2 independent variables. Now when you have 2 independent variables, the function will become y equal to a function of x1, x2. Since there are only 2, normally, okay, if you look at the book, they didn't use y, x1, and x2. We use z as a function of x, y. So the variables are now, instead of x1, x2 independent variables, we use a completely different set of letters. All right, z, x, y. So now, x, y are the independent variables, and z is the dependent variable. So for 3 variable case, or for 2 independent variable case, we normally write in this way. Okay, we use z as the dependent variable, function of 2 independent variables, x and y. They are the independent variable. Okay, all right. So we call this graphically, we call it three-dimensional graph. Or when you have two independent variables, it's three-dimension. Okay, or in the graph is three-dimensional graph, which is more realistic. Everything is three-dimensional. You know, human beings, all the objects in the world is three-dimension. You know, you have so far two dimensions. You have y as a function of x. This is two dimension. Okay, you have y and x. Go all the way there. So it's two dimension. What you get a line, okay? Or you get a square, or you get a cube, or you get a circle. It's like that. Now, when you put a another dimension, where you have z as a function of x and y, you will get three dimension. Okay, so that will be three dimension. Now, when you have that, how will the graph look like? The graph look like real life. Okay, so if you just imagine, you know, in your where you are now, in your house or in your dorm, you just imagine your room. Okay, the place where you're now. You have what? You have a room. It's three dimension. You have the width. Okay, you have the width of your room, and then you have the length of your room. Okay, just look at it, look around, and then what is the other dimension? You have the width, you have the length. Now for two dimension, that is the length, that's the width. All right. Now, if you have another dimension z, then what is it? Which was actually y earlier. Now it's no more. Okay. The x and y now becomes the surface, becomes independent variable, and you have z, the dependent variable, which depend on the x and y. But going back to your room, you have the width, you have the length. What is the other dimension?
Height.
You have the height. Okay, so that height will go away, will go up. Can you see the screen? Can you see my screen? Benda tu, okay. From there, where the width meet the length, the length, then you bring it up, so that becomes the height. So you imagine where you are now, you know, in your room or in your house or in your dorm. You have the length, you have the width, and then where the length meet the width, you have a height. The height, or you know, the other dimension is the height. So that is the three dimension: width, length, and height. So you have an object, all right? So instead of having a circle, you have sphere, okay? For three dimension, you have object, you have a sphere. Instead of having a rectangle, you have what? You have a cuboid, or you have cube, okay? So this is a real object, like us, you know, we are object. So we are three-dimensional. So now when you draw the graph on paper, then how do you do the graph? So I want you to go to figure 14.1. Okay, figure 14.1 on chapter 14.1. My book is page 861. Now what we do here is, for the height, not for the height, for the width and length, you do it this way, you know, to reflect the surface. So what we do it like this. This is the y, okay? That's the x. So in order to capture the dimension, you do it this way. Now every, supposedly lah, you know, even though you draw it not a straight line, but actually this should be 90 degrees. Okay, so you imagine that should be 90 degrees, just like what we were doing for the two-dimension object. So that one should be 90 degrees. So as a whole, you know, that surface is 360 degrees. So we make it slanting in order to capture the height. So the height will go up from there. So that's the height that you call Z. All right. So that is the dimension, you know. If you are in your room or I'm in my room now, I'm sitting here. Okay. That's me here now. Or imagine you are now, you are facing the wall, all right? So the bottom of the wall, that is the width, Y, that's the length, X, and that's the height. This is the inside of your room. The other way is the outside, okay? Down here is underground, is below your room, okay? That way outside, that way outside. So the one that is outside, you show it by a broken line. You imagine that one you cannot see, okay? Because we are here. So if you look at that graph, they show it by broken line. That means it's the other side, it's the negative side. And similarly for this one, you know, it should be negative because that one is below you, okay? So that is the graph. So we show it, you know, the part that is beyond the first quadrant, you show it by broken line. And how do you put the scale? Okay, the scale is just like the two-dimensional graph. So that part is the zero, the origin. So here is our zero. I think I'm going to use another color. Okay, ni zero. Okay, that's zero. Now for the y, it will go that way. So let's say this is 2, that is 4, 6. So going backward, -2, -4. Now for the x to the outside here, that is the positive. So you got 2, 4, 6. And then going the other way, the outside, that will be negative. So -2, -4. Okay. Now similarly for the z, going up, positive. Going down will be the negative. So -4, -6. Should be -2 here. Okay. But I don't have, you know, it may overlap with that 2 of x. So I put it there. Okay. So that is the scaling. Any question? Okay, next. How do you locate a point? Okay. Now, a point on that graph, we denote by this ordered pair, x, y, z. The independent variables will come first, x, y. Last value would be the z. So that's how you identify a point. Example, let's say I have 2, 4, 6. Now, how do we locate a point? Okay, this is how we locate a point. First, you take care of the x and y. All right. Number 1, you take care of x, y, which is equal to 2, 4. Locate that point first. All right. Now, what is x, y equal to 2, 4? Where is it? Where is it? Look at my graph. Where is it? 2 and 4. It's just on the surface. Okay. So x equal to 2, y equal to 4. Where is it? Anybody can tell me where is it? Somewhere here. X equal to 2, y equal to 4. So we go like that. So somewhere here. All right. Now x equal to 2, y equal to 4. You already know that's the point. Next, you match it up to the z. Okay, which is equal to 6. So x equal to z equal to 6 will be up here. All right. But now you have to match it, or you have to correspond it to that point, 2, 4. So that 2, 4 to match with the 6 or to correspond with the 6 W of Z, you move up. It'll be somewhere here. So that is our point. 2, 4, 6. Of course, it's difficult to locate. All right, difficult to locate. Why? Because it's 3 dimension, and our diagram is based on 2-dimensional paper. But the important thing is, how do you locate a point? Firstly, you start with the XY, okay, and then get the corresponding Z. So that's how you locate a point. Okay, all right, good. So we have done the things, and of course, to draw a graph is very difficult. So you don't have to draw the graph, okay? We don't draw a graph, we just imagine the graph. So for example, this kind of 3-dimensional function, you look at the book. Go to what example they give you? They give you one example on figure 4.2. Okay, figure 4.2a. Okay, that's an example of an object. Now, what object do you see there? What kind of shape we describe that thing? Anybody knows that kind of object? That is given by that function, you know, 4 minus x squared minus y squared. So if you have a book, how do you describe that shape? What do you call it? Kita panggil apa tu? Anybody know? Do you see that shape anywhere? Have you seen that kind of shape? Tak pernah jumpa? Huh? Have you seen that kind of shape?
Hello.
The cover of baby.
Apa dia? Kat mana jumpa?
Baby bottle.
Kat mana?
Botol baby punya cover.
Ubah aspek.
It's like it's not really a cone, you know. A cone, you have a sharp.
Ubah.
It's like a kubah. It's like a dome.
Bulat.
That more like a dome. So if you go to Istana Negara, you know, on the highway, or if you look at, I think some of the building in Putrajaya, you see a lot of dome-like. But most mosques in our country, you know, have that dome shape. Is that right? Unless, you know, if you go to Malacca, then the mosque is more like Chinese dome shape. But if you go to most mosques, you know, in other places, you see dome-like. Okay, so that is more like a dome. So that's an example. All right. Okay, good. Now what we want to do next is we want to do the derivative. So this is where we do the partial derivative. We call it partial derivative. How do we do the derivative? So we have, again here, z as a function of x and y. Now, as I said earlier, when you do the derivative, why we call it partial? Because we do the derivative only for one independent variable at a time. All right? So that's what we mean. When you take the derivative, you take the derivative of z with respect to x. And then I take the derivative of z with respect to y. So that's why you call partial derivative. You take the derivative of the dependent variable with respect to one independent variable at a time. So you differentiate, okay, z, we call it with respect to, here with respect to, WRT, to one independent variable at a time. Now, what do we do with the other independent variable? The other variable, the other independent variable we keep constant. Kept constant or assume constant. Or we assume, okay, or kept constant. Assume constant. So for example, I take the derivative or I differentiate. That means the partial derivative, we don't have to call it partial now. Differentiate z with respect to x. Because one at a time. What do we do to y? Y, you kept constant. Or we assume y constant. Now, you do the other derivative. We differentiate z, okay, with respect to the other variable, y. What do we do to the other independent variable? Kept constant. So now x will be kept constant. Now, x and y are not constant. X and y are variable. But when you do the derivative, all right, for example, you do a derivative of z with respect to x, you just think, okay, you keep y constant. You just imagine, you assume that y is a constant. Or when you do the derivative of z with respect to y, the x, you imagine or assume constant. Okay. Actually, it is not constant, okay? They are variables. But when you do the derivative of one or with respect to one independent variable, the other variable you assume just to be constant. Okay, all right. Now, notation. When you do the partial derivative, we write similar to the derivative, but with a slight difference, okay? So notation, you got z as a function of xy. So you got dz, dx. So the d is the slanting d, the Greek d. Or we can, you know, this one is more familiar. We just call it zx. So that is the partial derivative of z with respect to x. Or we call it fx. Now this is like a subscript, okay? Not multiply, okay? It's not z multiplied by x. The x is subscript. So zx, okay? Or fx. So this is the notation, this partial derivative of z with respect to x, keeping y constant, okay? The other one, you take derivative of z with respect to y, keeping x constant. So you got dz dy. You can write also zy, or you write fy. Okay. All right. So that is notation. So now let's do the derivative. Okay. So let's consider one or two examples before we end the class. So example, let's say you have, okay, we have z equal to f of xy equal to, say, 4x squared minus 3y to the power of 5, negative 5. I prefer, you know, this thing here, you know, I prefer to write it, that one, rather than using the zx, sorry, but you can choose your own. But this one, of course, you know, you take longer time to write. So let's do fx, the derivative of the function with respect to x, or you can write the all right. So now, when you take derivative of z or the function with respect to x, what do you do to y? We assume y constant. You keep y constant. So that y here is a constant. Imagine, constant. So just think of it as a number, probably 10. Okay? All right. So with that, we do the derivative. So the only variable now is x. So you take derivative of the z with respect to x, what do I get? I get 8x. Okay? Just derivative is just like a regular derivative. That means all the rules, okay, all rules of derivative that we learned earlier hold. There is no new rule, okay? The rule we already learned. Now, that y is a constant. Of course, 3 is a constant. Y is also a constant. Imagine it's a 3 or 10. Now, what do you get? The derivative of that second term. 3y to the power of -5. What is it equal to?
0.
0.
Equal to 0. Okay? Because you assume it's a constant. We assume it's constant, so plus 0. But of course, you don't write 0 lah. Okay? So you just keep it like that. So that y is a constant. Okay? Think of it as a number. Example 10. So derivative of a 10 is 0. All right? Now, take derivative of the function with respect to y or zy. Now, when you do that, the function that you assume variable now is x. Okay? So think of the x as a number, say 2. The variable is y. Okay? The y is a variable. So let's do the derivative. Now, this is a constant, x. So what is the derivative equal to? Zero. Okay? So that is 0. So you don't have to write. The one that you need to derivative to find the derivative of is, of course, the second term. So that y is a variable. So what do I get? Take derivative like what we do normally. So that becomes -3 multiplied by -5. Okay, reduce the power by 1, so that becomes -6. So that is equal to 15 y to the power of -6. So that is the derivative. I mean the partial derivative. When you take derivative with respect to one variable, the other variable you keep constant. Okay? All right. So we will continue next week after the break. So for now, forget about this. Okay? I want you to study the other chapters which will be included in the quiz. So don't worry about this one. This one we worry only about after what? After the quiz. The quiz is on when? Tadi saya cakap apa quiz? Hari apa? Saya pernah lupa lah.
Rabu. Wednesday.
Wednesday.
I have to record down. Hari apa kita beritahu tadi?
Rabu.
Wednesday.
Okay, Tuesday, 10 a.m., right?
Yes.
Wednesday.
Wednesday.
Rabu.
Yeah, Tuesday ke Wednesday? Let me confirm. You know, we have to confirm this. I will confirm this.
Wednesday.
Wednesday, sir.
It's Wednesday. Is that right?
Yeah.
So
Yes.
before you got the day and the time correct, okay? So that is Wednesday on the 25th, 10 a.m. So I hope, you know, given the extra time, you can prepare better. And I hope everybody will do well. So I will see you again. Have a nice weekend. Okay, so rest and then study. So I will see you again. Assalamualaikum warahmatullahi ta'ala wabarakatuh.
Waalaikumsalam.
Thank you, sir.
Okay,
Waalaikumsalam.
Thank you, sir.
Okay,
Thank you, sir.
Thank you, sir.
okay, thank you.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
Waalaikumsalam. Assalamualaikum.
Thank you very much, sir. Have a good day.
All right, thank you.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.
Thank you, sir. Have a good
Okay,
weekend.
thank you.